Do subscribe to eKida channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Students, today we'll discuss about another physics paper, JEE Mains Physics 2014. So let us discuss all those questions one by one. Okay. Students, let us solve the next question. Question number 23. The question is about the lens ray optics chapter. A thin convex lens made from crown glass, mu is given. So a lens which is made of a glass, but here we have a crown glass whose refractive index is 3/2, has focal length f. When it is measured in two different liquids, it has focal length f. When it is measured in two different liquids having refractive indices 4/3 and 5/3, it has the focal lengths f1 and f2 respectively. The correct relation between the focal lengths is, that means what? This is a thin convex lens, refractive index is given and focal length is f. So this focal length is basically the focal length when it is kept in air. Okay, nothing is given means when it is kept in air, that focal length is f. But when it is immersed in two different liquids, first it is immersed in a liquid whose refractive index is 4/3, then you take it out and then dip again in another liquid where the refractive index is 5/3. So in two different situations, we know that the focal length of a convex lens or concave lens depends on the medium, also depends on the surrounding medium in which it is kept. So that formula we know is not absolute formula, that 1/f, this is called lens maker's formula. 1/f equals to mu minus 1 into 1 over r1 minus 1 over r2. This formula is not absolute formula. This is for when it is in air. Then this refractive index of the material what is given here is put here and then you get. The focal length also depends on the radius of curvature. As you can see, the radius of curvature of the lens. So, but here this is kept constant. So we have got three medium actually. One is air. Next, another we have where the refractive index is 1. Another liquid, suppose liquid 1 is refractive index is 4/3. The second liquid it is 5/3. So in all these situations we have to find the, so in this case the focal length is f. Here the focal length whatever comes out is f1. Here it is f2. Now after you find the value of f, f1, f2 using this formula, then we'll relate whether f1 and f2 are equal, or f1 is greater than f, or f2 is greater than f, or which type of relation that you are going to get. So to do that, I will have to use this equation 3 times, one for this, then for this liquid and that liquid. So 3 equations we'll get and then we'll compare. Now 1/f is mu minus 1 by r1 minus 1 by r2, where if this is a lens, then this surface has radius of curvature r1 and this has got r2. Okay, this has got radius of r1, this has got radius of r2. Now mu is refractive index of the material with respect to the medium. So this is refractive index of the glass with respect to air, minus 1 1 over R1 is the first. This is a refractive index of glass by refractive index of air minus 1. And then for air, which focal length is f, this is air, this is refractive index of the material of the prism glass is given as 3 by 2. This is given in the question. So if I put that, I will get 1 by f equals to mu g, which is 3 by 2, mu a is 1, mu a is 1, so minus 1 into 1 over R1 minus 1 over R2. If I solve this, then it is 1 by 2, 1 by R1 minus 1 by R2. Now, if I use the sign convention, then it will become plus, because this R1 is positive and this is negative. So with sign convention, R1 is positive, R2 is negative. If I put that, focal length of a convex lens is always positive. If I put that, I have 1 over f equals to 1 by 2 into 1 by R1 plus 1 by R2. Because R2 is negative, so negative becomes positive. This is equation number 1. This is for air. That means the lens is suspended in air. This is situation. Second situation is when the focal length is f1, then I will use the formula refractive index of glass divided by refractive index of the liquid 1 minus 1. This is the formula I have to use, which is 1 upon R1 plus 1 upon R2 with sign. So this mu is again 3 by 2 divided by refractive index of liquid, that was 4 by 3. Okay, this is 4 divided by 3 minus 1, and this is 1 over R1 plus 1 over R2. If I solve this, this is 3 by 2, 3 by 2 and 3 goes up, so this is 9 by 8. Okay, 9 by 8 minus 1. So this 1 upon f1 comes out of this, which if I solve it, then this is 1 upon 8. 1 upon f1. This is f1 and 1 upon f1. So this is equation number 2. When lens is suspended in liquid 1, this is the formula. Next, when it is suspended in liquid 2, for lens in liquid 2, 1 upon f2 focal length comes out to be mu g by mu L2 minus 1, 1 over R1 plus 1 over R2 with sign convention, and mu g is 3 divided by 2 divided by, this is 5 over 3, I suppose. Yes, this is 5 over 3 minus 1. If you solve this, then this is 9 by 10, 9 by 10 minus 1 and 1 over R1 plus 1 over R2. This comes out to be minus 1 by 10, 1 over R1 plus 1 by R2. This means that the lens has changed its nature. Means the lens, convex lens, behaves like a concave lens when it is suspended. If it is put in a medium whose refractive index is more than that the refractive index of a lens. This is a very important conclusion you must also learn, because 3 by 2 and 5 by 3, 3 by 2 is always 1.5 and 5 by 3 is 6, something like that. So you can see that this number is greater than this number. That means the lens whose refractive index is 1.5, if it is kept in a medium whose refractive index is more than this, say 1.67, then this lens will behave like this lens. That means the convex lens behaves like a concave lens. So it changes nature. But anyway, so after you got these three relations, then we have to compare the results. So we have first equation 1 over f, which is equal to 1 by 2 1 upon r1 plus 1 upon r2. This is the equation number. Second equation, we got 1 upon f1 equals to 1 upon 8 into 1 upon r1 plus 1 upon r2. Okay, so you write those two equations. Then the last one, 1 upon f2 equals to minus 1 by 10 1 upon r1 plus 1 upon r2. This is the equation number 3. Now we have to see the option. After you got all those f1 and f2, the question is which one is greater, whether f1 is greater than f or f2 is greater than f. So if you compare this, then you can see this from here. If I want to find f1, then it will be reciprocal. That implies f1 is the reciprocal of that. This number is same in all the cases. I can just eliminate this. I can assume that this is 1. So f1 is proportional to 8, f is proportional to 2. So f1 is 4 times f. f1 is 4 times f. You can just see that here is directly proportional, so it is 4 times. So this 2 here, 4 into 2 I can write. So this is how it is. So f1 is greater than f. That means from here I can write that f1 is greater than f. It is almost 4 times f. Next is that so if I see the option f1 and f2 are equal, no, they are not equal. Here it is negative, here is something else. So first option is not correct. Second option, f1 is greater than f, that is correct. F1 is greater than f, and f1 is greater than f, and no options are there. Whether f2 is greater than f, no, f2 is negative, it is not greater than that. So the best choice would be, what would be the best choice? If I see this f2 is negative. Here you can see it is negative, implies it has become a concave lens. Means it has become, means it behaves like a concave lens. So the nature has changed. So if I combine these two results, then I'll write that f1 is greater than f and f2 is negative. This conclusion I can draw. So if I see the option, then f1 is greater than f and f2 becomes negative. f1 is greater than f and f2 is negative. So therefore the option number 2 is correct. Therefore this answer is correct answer to this question. Okay, thank you.